solution can offer, and specifically the i500, regarding the orthodontic side. So let's begin and see. So, 30th of June today, and as I said, we start with orthodontic stuff. So, what you should know first, metal brackets scanning. Keep in mind that we are one of the least companies that we are scanning very easily and accurately the metal brackets, even without using scanning spray. How we do that? Well, it's very simple. What you need to do only is that you need to rotate the scanner from multiple angles so that the light will reflect from different angles on the surface of the brackets, and through this way the system, by having all the data that it needs, will combine them all together in the post-processing, and then you will have these amazing results that you see here on the slides. These are cases that were created from users. They're not cases that are created from us. So as you can see, everything can be done. It's not impossible. It's not marketing. It's not just promises. It's proofs and facts, as you see here. And there are cases that are posted almost every day in our Facebook group. And you see here also another case with metal brackets. So there is no limitation regarding the scanning of the brackets. In case you would like to scan them, you can scan them easily. You just need to know the way, which is simple and clear. We use the scanner in such way that we scan from multiple angles. So you rotate the scanner from multiple angles, and that's all. You don't need anything else. So another important tool that we added recently is a specific tool. What you can specifically on the tool with with the measurement tool, you can perform measurements like that, as you see in the screen, and you can provide easily to your lab all the information that they need to know, or to your solution provider regarding the treatment, or anybody else that needs to know that. So you can take all these measurements, and of course you can take screenshots through medit scan, which can be saved in the case folder, and then you take all these measurements and all these information and you can send them through medit link. Again, we see other measurements here for the lower jaw in the same way. This can be done easily through our measurement tool. Also here, and here also for the lower jaw. And also you can even measure accurately the distance between the interproximal areas of each tooth. So you will know precisely, or even your lab or anybody that will provide you the treatment, how much is the space that you have between the one side of the tooth until the other. Here you can see also a measurement for molar. And the other tool that you can use for the orthodontics is also the Ortho Capture tool. Keep in mind that this tool allows you to take these pictures that you can use for the diagnostics and for the treatment, and you can also provide them, and you can have them included in the case folder, so you can provide them all through medit link, or even in case you would like to export locally your data and send them to your provider, you can send them also through email or with transfer or with any other way. Workflow, the scanning orthodontic, we need to create an orthodontic form. Orthodontic form we create through medit link, as always, and then you can scan the upper jaw, you can perform measurements if you would like, it's up to you, and always I highly recommend to change the display mode from color to reliability map in order for you your data are one that any other running so user, or even if you're an experienced user, it's always helpful. Even me, can lower jaw again and switch from with the display mode from reliability map. And last but least, we scan the occlusion, which I always say that in order to have a precise occlusion capture, you always need to make sure that your data are always clean and nice, and specifically from the areas that we need to capture the occlusion. I'm talking about the buccal sides, from the last molar that you maybe have available in your mouth until the canine, all this area for the upper and the lower jaw, we need to have clean data, crystal clear, and of course with sufficient capture of the tissue in order to increase the reference area that the scanner will use for the matching. In the end, you will be able to choose between to create a standard digital model, which is what I recommend, especially for those that they send the data to another provider for 3D printing, for performing the treatment, and so on. And of course, we provide you the option through the Create 3D printable model to print instantly in-house your own model for your own use. It's up to you. But what I always recommend, please don't select the second option, especially when you would like to send to somebody else to perform for you the treatment planning, the team to be able to print you. So always prefer the first option when you outsource your treatment planning. If you do it, I always recommend, but it's up to you how you would like to use it. In this moment, I would like to check if we have some questions here from anybody regarding the tools that I analyzed or the Solu, our platform. Of course, in the near future, we will have even more features. But for now on, the tools that we always use for orthodontics are the tools that I mentioned. Another important thing that I would like to mention here for you to be able to use is also the close hole. Close hole option is located now inside medit link, not in medit scan. Okay, so in medit, when you are in the case folder, you will be able to get there and check your models for any kind of holes. So before you send it to anybody else or outsource your files to any provider, make sure that you provide him models or scan files without holes. It's important for all situations, even for the treatment planning, even for the 3D printing, for everything. So this is where my part is ended. So now I give the wheel to my friend Frank, so he will be able now, from now on, to start his presentation about GuideMia, what his company is offering, what they are doing, what capabilities has his software, and so on. So Frank, I give you the wheel so you can proceed.
Okay. So can you switch it to the video?
Okay.
Spires,
Okay.
could you switch the video?
Sorry, Joe.
Okay, again,
This
thank
is
you
yours.
everyone to being with us. It's
Okay.
an amazing scanner, amazing technology. When the virus locked us down, it's the best time for us maybe to open our computer to look at the technologies we have today. Okay, today we're going to introduce our orthodontic solution and using intraoral scans from medit, and of course we can support all kind of file formats and scanners. But during the past couple of months, we have validated medit scanner and really find it's a very good scanner, with good model qualities. Okay, yeah. So let's start
Talk
this.
about
So we have orthodontic software that can do both aligner design and bracket bonding guide design. With the aligner design, we have the functions to do all the treatment planning and model design. And a little bit about us. GuideMia was established in 2012 in California and 2014 in China. We have both implant software and orthodontic software, and we're not very well known, but more people know us in the implant area. Actually, we were the first open system for implant surgical guide design, and we are actually the second orthodontic software approved by FDA. So let's take a quick look at what some major tasks we might have in orthodontic aligner design. First, you have load the patient scan, mark the medial distal axis, then we can extract the tooth boundaries and extract the teeth. Then we will do like automatic arrangement and also do manual arrangement like that. We simulate the movements. And we can also check the occlusions. We can generate, we create a virtual rendering of the teeth, even from the model scan, and then we can add brackets. We can snap all the brackets onto the same occlusion plane or different planes for both lower and upper. Simulate the movements of teeth, brackets, and the deformation of the arch wire. Then we can generate a report which has the movement statistics, IPRs, occlusions, slides for the teeth movements. So those are the major things you would see in orthodontic software. That's the major tasks are tooth metrics and segmentation, arch curves and tooth alignment, soft tissue remodeling, occlusion checking, movement simulation, and reporting. Now let's take a further look at what the major things in workflow, major tasks. So we're going to go over those major tasks in a workflow, and then we're going to do actual demo. So the version of the software we have just seen is our clinical chairside system. It can perform treatment planning within 10-15 minutes, depending on the cases. Now let's look at other tasks. GuideMia Orthodontic software is actually the only one, the first one that can integrate both CBCT data and model scans. Here are a couple of slides showing how we register the model scans with the patient CT, we segment tooth roots, and we create realistic rendering based on even the model scan and based on the CT data, so we can have full anatomical information so that we can ensure the treatment plan is safe, is feasible, and we have functions to load the patient's pictures too. We can overlay the picture with the scans. The pictures can be photos, it can be x-rays, panoramic x-rays, and they can also be DSD designs. And we have facial scan function integrated. You can load multiple scans, either a facial scan or restorations, and we can do a registration of them. and perform the simulations. Like in this one, you have facial scan and simulation. Other tasks in early stage of the treatment planning include create models. Like this one, we trim the model and close this model in just one single operation. You got a solid model, even if you get it from intraoral scan. So that's a very convenient tool for us to create dental models and use it as a base for treatment planning. And for aligner design, there is another very important task. So after the tooth segmentation, we want to smooth the boundaries. Please look at the tooth boundaries in this short video. And also there are interproximal areas that has missing surfaces. We can just use one mouse button to fix all of them in an arch. Now you see the interproximal area has been fixed. With us, this is a very easy step, and sometimes you don't have to do that. We can still very well maintain the tissue and the crown boundaries. And in an ideal world, you get good scans, but this is the reality. It's a very common task in orthodontic software to fix a model like this. So we have global fix, we have aerial fix, and spot fixes, all those functions to fix the scan models. Of course, you're not getting those kind of qualities from medit intraoral scanner. We can tell this one is might be from a model. You can see we select an area, fix this, and we can maintain a good shape and smooth the model, local area. So those are the tasks in the workflow. At the early stage, we prepare the data. We do CT data reconstruction, registration between CT, model, intraoral scan, facial scan, and we can load clinical pictures, X-rays, as well as DSD design. Do data segmentation from cone beam CT, clean up the optical scans, closing holes, remove small spots, artifacts from models. We can fix in crown boundaries and interproximal areas. Those are very important tasks, not only for just to have easier, more successful model processing, but also for a full anatomical model, especially with the CBCT and the DSD design kind of information that can help you perform good treatment plan that is safe and feasible. In later of this webinar, we will see cases that we actually align teeth with roots, with crowns. So other tasks including to control the movements. Here we set the two molars are fixed, so we cannot move those teeth during the treatment plan. And then we can also perform tooth extraction with just one mouse click. So you see the teeth are removed, the tissue area is fixed. Sometimes for the aligner purposes, we can create pontic in the middle, or we can remove the tooth completely. And when we adjust the teeth, we not only adjust the positions of the teeth, we are actually adjusting the occlusion and IPRs as you see in this clip. Again, this is our chairside clinical version of the software. It has complete workflow of major functions you need for treatment planning and basic aligner designs, but it has a much simpler user interface comparing to our designer versions, which have this one is the designer version. And of course we got to have the attachment functions. We got to have power reach functions. We can create base models for printing. Sometimes people want to print the models vertically, then we can add base models for that. So those are the tasks in the treatment planning stage. We need to set tooth move, can be moved or cannot be moved. We do tooth extractions. We have, besides automatic tooth alignments, we can do manual adjustment, attachments, power ridges, brackets, and arch wires, as we shown in the first short clip. We need to adjust the brackets, adjust teeth, attachments, etc. And also we can do lingual brackets, and as long as we have the libraries of the brackets. So those are the major tasks you would need before you actually get into the movement plan. You need to have those basic functions to move your teeth to the final positions, the target positions. Now we are simulating the movements after we have the final tooth positions. This video clip is created with medit intraoral scan, and with also for the crowns with our rendering. It's not the color from the scanner itself, so we have the options to switch between the scanned color and virtual color. We simulate not only the crown movements and tissue deformation, we can simulate the roots and the bones. So this way you see not only the crowns, you see how the roots are moved and how they interact with each other. Over time we have found out that with cone beam scan, with the tooth root models, it's actually a lot easier and faster for us to perform the tooth arrangement. So it's a lot easier to find out where the ideal positions and orientations are. Without roots, as we say, the crowns are only a third, maybe half of the total length of the teeth. It's very subjective to say if the crown orientation is good or not, but if you have roots, it's a lot easier. Here we show the stages of the movement. That's another task. We need to plan the movements of the teeth, not just the final positions. We would have stages to determine some teeth move first, some move later, and we can also define in the middle of the movements you may want to stop for a while. Those kind of operations we need to do this in the software. So that's besides the simulation, we actually need to plan and simulate the stages of the movement. Sometimes they cannot just move all together. It has to be have some sort of orders. That's how the movement plan is doing. And also the simulation with brackets. In this case, we show tissue, crowns, brackets, and arch wires. They all are moving or changed. So with the bracket bounding module, we can actually determine how the arch wires will be changed during the treatment course. With the technology to customize the wires, you can probably do a staged fixed orthodontics treatment. This one is a very interesting one. You see, we adjust the teeth, and in the middle we just adjust the jaws. So this way we can find the optimal position of the jaws and then we can simulate the tooth movements at this position. We don't just set the jaws to be fixed and move the teeth to meet each other. With this approach, we actually do 2 stages of the plan. We find the best jaw opening angle and positions, and then we plan the tooth movements. This way, it's a lot easier to maintain good looking of the jaws, and also to minimize the tooth movements with the optimal jaw angles. So to summarize those planning and simulations, we need to allocate the movements between the steps, create stages of the movements to simulate crowns and tissues, simulate roots, to simulate articulations with the 2 jaws. And you can tell from the articulation simulation later on, we can load videos of the jaw movements and to do a lot more work. We can simulate the brackets and arch wires, and of course need to dynamically detect the collisions. Now let's get to the stage to create the models. Here we can create attachments, power ridges, simulate movements, add case tags, and generate aligner models. With all the aligner models we generate, we have very good model quality. We can look closer to see how the meshes are, and how the crowns and the teeth are put together, crowns and the tissues are put together. So we generate all those staging models in one step, just one mouse click. For brackets, we create multiple things. This model is the stone model. Can be a stone model for you to do traditional indirect bonding. You print this model, bound brackets onto the model, and do a thermoforming to create a bonding guide, bonding chains. That's a conventional way to do. And we have our own technologies to do we call direct bonding, or call adaptive direct bonding guides. And this is to simulate the movements of the brackets. We later on in the software demo part, we will show how the bonding guides are created. So this is a bonding guide design module, and those metal pieces you see above the teeth are the bracket extension structures we come up with, and which is a patent pending technology, and the whole design has been validated, and it's very easy and convenient for the bracket bond. So this is a process to design the bracket bonding guide. And we can also create windows for acid etching, like in this one. We also have the bracket anchorage implant surgical guide. As we have been doing implant software for years, so it's a very easy and piece of work for us to integrate the anchorage surgical guide into this orthodontic system. So this is anchorage implant placement. If you have an implant STL files, you can replace the anchor pin shape. And so you can design the surgical guides. So of course you can change the different size of the implant. So those are tasks in the design process. We can design aligner models. bracket bonding guides, acid etching guides, models for indirect bonding, surgical guides for anchorage implants. And we didn't show this in the slides, but we will have a part in the video later, in the demo later, to do a replan. As we know, it's becoming very common. You have to restart aligner treatment during the process because the aligners no longer fit onto the patient's mouth. So what we call is replan. We take a scan in the middle, and we can automatically register the scan with the existing plan to find the closest step in the previous plan, and we start from there to automatically generate the rest of the plan and to generate the models. That's what we call the replan module in our system. We can show this in a while later. So here to summarize this major functions, advantages in our system. We have protocols with CBCT facial scan. We can do a realistic tissue remodeling. As you see, all those tissue deformations, it's very realistic. Automatic tooth segmentation, fine movements adjustments with staging, automatic replan for aligner restart. We can do user-defined attachments, user-defined power ridges, etc. And we can do automatic aligner model generation, generated report with APRs, with occlusion maps. We can visualize the occlusions during the tooth movements. And we can do automatic bracket placement, and we can of course open to new bracket brands. Just to talk a little bit more about bracket bonding, and in the future we're going to release a direct bonding guide that is independent of the bracket brand and size. That way, regardless what kind of brand you have, the guide design will be the same and the treatment planning will be the same. You need a special tool from us. So in the software system, we have built very long time manufacturing experience for ortho aligners and lots of clinical experience into the system. This has been for years for us, so we work with clinicians, especially with for implant system. We work with lots of implantologists, so we build their requirements, their expertise into the workflow. That's also what we are doing today. So with our system, now regardless you are a aligner manufacturer or you are dental offices, hospitals, you can do aligners, bracket bondings in office or in your manufacturing facility. So you can start with the patient's scan, and the very interesting thing is if you do this in-house, you can actually make the first set of aligners on site before the patients leave your office at the first time. And later on you can finish the treatment plan and make some aligners. And when the patient come back, the patient has already got used to the aligner material, and so it's a good time for you to just deliver the first set of aligners. So that's an overview of the system. Now let's get into a demo of our chairside system. We load the entire scan from medit first. Then we define an occlusion plane of this arch. We typically need 4 points. We got a plane and we make some adjustment. So this is for chairside version. As you can see, the user interface on the lower part is step by step, very easy to follow. Now we load the lower jaw scan. Now in one step, we're going to trim this scan and close the model to create a solid. you adjust the orientation, the size. Now we fix trim and fix it. Next, we're going to mark the mesial distal orientation of those teeth. Those numbers are the rough numbers. They are not the actual tooth width. In our report, we are going to regenerate all those tooth metrics. This is just to give you a rough idea how big the teeth are and how what the mesial distal orientation is. So we mark the orientations, then we can extract the tooth boundaries and extract the teeth. So this is pretty much all the input you would have to do in the preparation stage. Now the crown boundaries have been detected and some are not actually finished. We can just easily adjust them and segment the teeth. Now next to this one, we can try to drag the boundary. And in our system, when we adjust the crown boundaries, we don't just go around the tooth. We simply drag those handles, and the system will try to figure out a path for boundaries. Now we segment all of those crowns. Basically, after we define the boundaries, the segmentation is automatic. And in reality, you always could have something, that cannot be extracted as in this demo. We're not in a perfect world. So let's see how we are going to fix those things. We simply rotate the view a little bit, and then we can regenerate the boundary and extract the crown. You just repeat this process. You don't have to check the boundaries manually. Now we finish the segmentation of the crowns. And then you see those red curves, mesial distally and buccolingually. So those are the FA curves, and which indicate the orientation of the teeth. So in this step, we are trying to adjust the orientations box so that they actually are consistent with the teeth. The reason we are doing this is later on we are going to do automatic bracket placement and also to automatic tooth alignment. So those orientations play a critical role in determining when we trying to determine the orientation of the teeth and to do the alignment. So we can look at this view from different orientations to define the orientation of the crowns. Basically, the axis is what we are looking at, and also the occlusion plane. We do the same process for the lower jaw. And as we did for the upper jaw, we're going to segment, find out all the crown boundaries, and then adjust them and generate the crowns. So there are a couple of areas we need to adjust the boundaries. Like this one, it was not successful, but you can see here, only thing we need to do is just to drag one handle. We don't have to walk around the crown boundaries and to redraw it. Just drag one point. And we segment all the crowns in one step. So in the first try, I didn't notice two of the boundaries are not closed. And we do an easy fix of those. And this one too, the boundary was not perfect, so we delete it. So that's how you get in a real scan. So we are not, again, we are not in a perfect world. There's always situations, but we have an easy way to fix them. So you see how we drag the boundaries. Now the segmentation is all set. Again, we adjust the orientations as we did for the upper jaw. Now we get into the automatic arrangement of the teeth. So we create arch curves, two arch curves for each of the jaws. One is the ideal arch curve determined by the current width and depth. Another one is what the current arch curve is, so basically according to the current tooth positions. We can choose to adjust either of the arch curves and to align the teeth according to the arch. So by default, we use this ideal arch curve to align. In this case, we need to move the lower anterior teeth lingually. So we move the arch curve a little bit toward the lingual side. At the first step, the arch curve of the upper jaw is generated according to the current lower jaw positions. So they are correlated at the beginning. So you know with the current tooth orientation, the ideal position of the arch, the upper arch, will be a little bit wider than what it is. When we do automatic alignment, we can choose a percentage. For this one, we choose something like a 75%, 70%. So we can do an automatic alignment, and then we can check whether the positions are good, the occlusions are good, and then we can further adjust them. You see we have to do the initial automatic alignment. And here we show the upper jaw, lower jaw is a little bit translucent. Then we if we want to make change, we adjust the percentage a little bit more. And now we are going to finalize it. That will regenerate the tissues too. So here we are seeing the simulation of the crowns and the tissue. Of course, the current movement is just equally distributed between the steps. So we define a limit of allowed movements in one step, and let's say 200 microns, and we automatically generate the steps. But later on in the designer version, we can make a further adjustment. Here we can do a slight movements of the crowns, so that's a manual adjustment. In our design version, we'll show later, we can set predetermined IPR values. Let's say you don't allow IPRs, then you can automatically move all the crowns to the positions so that there's no collisions between the crowns. So the target position definition is just these two stages: automatic first, then we do manual adjustment. Since we haven't done 100% in this demo, so you see the positions are not ideal, so we can further adjust. We show the occlusions here. The distance between the jaws, the teeth, and the antagonist were determined by, were reduced to the minimum, and of course for actual design you have to make slight adjustment like we are doing for the anterior teeth. And also we have fine movements control. You can do buccolingual movements, mesiodistal, extrusion, intrusion, rotation, torque, etc. So you can do, instead of just moving the crowns with the placement widget, you can do those fine movement control. And in the meantime, the system is going to show you the current IPR values in the left side of the screen. So when we are moving the teeth, as we are showing here, the crowns are always following the teeth. So it takes a little bit time to do the recalculation of all the tissues. The tissues are following the crowns. What we can do is we can hide the crowns. We can hide the tissues so that the movements can be a lot easier and faster, and after we are done, we regenerate all the tissues. Now in the clinical version, we can also do some movement control. We show the numbers on the left side of the screen is the steps and how many microns are the translations are in each of the steps. This is to generate the report. So we automatically generate a report which will include patient information, doctor information, statistics of tooth movements, screen captures, and slides. So those are the movements. It also has the Bolton index here, IPR values, the original positions, and aligned positions, occlusion map, simulation of the movements in slides. And of course, later on, we are going to put um, web app to actually let you to view the movements of the teeth. Those are just slides, but we can put this report into our website so that the users can review them. So that's the part of clinical side of the software. So this is what we are doing. We have a clinical side of the software which can start a case from the scratch so that doctors don't have to send the data to the lab. They can have their assistants or lab technicians to perform an initial treatment plan within 10-20 minutes, and then they can send the case to the doctor, to the labs, to finalize the design. And what's showing here in this the current screen is, on the other hand, if the lab perform an initial design, they can send the software and the treatment plan case data to the doctors, so the doctors can set up the software, activate the software, and then they can view the case and make the final adjustment. So for the workflow ways, we can work both ways, from dental offices to lab, or from lab to the offices. So if we go from lab to the offices, here's what you are saying. As a doctor, you open the case, review what you have, and then you make the final adjustment of the plan, sent back to the lab. So this is what pretty much it's a similar thing to CleanCheck, and it has some more functions because we can actually start a case from the scratch. This is a little bit different from others system too. So again, we support two-way workflows. Now I'm going to skip this a little bit, see how the design version of the software works. On our website, we actually have a portal, so you can define the case, upload the case, if you want design services from us. So if in that case, you're going to get this software, and you're going to have this video to review how you can review a case. Now let's get to the design version of the system. It's in the clinical version of this, we have shown the core workflow, but in the design version, we have lots of more functions to deal with the actual world, to deal with the complexity of the clinical cases. Now this is our design version. Core workflow wise, since we have seen what we have in the chairside version, so those are the pretty similar steps, but in a different look and feel in the user interface. Similarly, we first load the upper jaw scan, define the occlusion plane, and load the lower jaw scan. In the function, in this step, we can load the patient picture first. When we are trying to determine the midline as we are adjusting the occlusion plane here, we are just trying to follow the center point of the two anterior teeth, but it may not be true. By the way, this picture is not actually for this case. This is for demo purposes. So when the midline of the actual patient is not same as the two front teeth, what you want to do is you want to refer to the pictures to adjust the occlusion plane. So that's why we have the pictures in this step. And also we can have facial scan in this step. So users can load the facial scan and register the facial scan with the jaws. And here in the middle of the left side panel, there are a couple of functions to fix the models. The first one is for quality issues, as we often see quality issues from STL files. So we have global fix, or we also have aerial fix, as we shown in an earlier demo. Now for this scan, you see here we have more boundary control than what we have in the clinical version. We can define the boundary of the model and trim and create a solid model out of it. That's what we are doing in the demo. I can adjust the boundary. We do the same thing for the lower jaw and upper jaw, so we do both of them. This way you can have a very detailed, accurate control to the model boundaries. So typically for the purpose of simulating the soft tissue and to create a good solid model for the aligners, we leave like 4 or 5 millimeters margin on the tissue area. Then, as in the clinical version, we can close the model, create a solid. Then we go to tooth segmentation. As you can tell here, we have more things. We have CT, root segmentation, we have extraction functions. We have included everything for the model preparation in this page. So I'm going to skip a little bit about this crown segmentations. So we do the same way for the lower jaw and for the upper jaw. In this demo, actually, the jaw segmentation is better than in the last demo. You know, adjust the orientations as we do for the for another version. So it's the same process. So lower jaw, so we got the crown boundaries. Actually, for this one, we got everything right in the first step. And then we segment all the crowns, adjust the orientations. We also have the similar steps to smooth the boundary of the crowns. And then we fix the interproximal areas like this. Again, just one step, we'll fix all of them. We save the project for a moment. Even though the system has full project recovery functions, it's always a good habit to save the projects in the middle. So if for any reason, let's say power outage, the system is down, next time you can always recover the data. Now we go to alignments. So this is different from what we have in the clinical version. You see the tooth colors are different because the anterior teeth has been fixed. We have added interproximal areas. And the same arch curves are showing here, but we have more control on the workflow. We can better define the arch width and the curveness of the arch curve, and then we can simulate different situations with this design. This is what we're doing. We adjust the width and we adjust the move the total arch curve lingually on the lower side. This is similar to what we had in the clinical version demo. We do a manual adjustment of the arch curve, or we just can adjust the curveness of the curve. So you see here, now we go back to adjust the arch curve with the sliders. And we can combine the two operations, the global curveness and width control, and also the fine adjustment of the curve. It's very important here to have a good arch curve. This way the alignments can be faster, and you can have better control to the shape of the arch instead of moving the teeth one by one. You do it the global way. And also on the left side of the workflow panel, we have buttons to automatic adjust IPRs, automatically adjust the occlusions. We have all those things. So we spend a little bit more time on the arch curve adjustment because we want to get good results at the beginning. So we are showing different ways to do this adjustment. So this is to control the upper arch curve. Essentially, every arch curve configuration can give you a quick alignment plan, so you can just review and choose one of those. So this is how we are doing for the automatic alignment. Similarly, we adjust how much percentage we want to do in the first alignment. So you see from here, let's show the crowns too. Let's show the tissues too. We'll do some slight adjustment, and then we can finalize the plan. So when we hit final, it's going to recalculate everything and regenerate soft tissue models. Now I skipped one thing here. Now we finish the creation, and we also generate the virtual rendering for the crowns. Now you see the color, they are no longer from the original scan. It's a virtual color. It looks brighter. And because we, as we said earlier, we actually change the shape of the crowns when we fix in the interproximal area. This is why we are doing something different, showing different colors now. But this, to finish the automatic arrangement, and then we go here to review the plan. We can play back the movements, and then we can go back to adjust individual tooth. So you see here we can set the, on the left side of the workflow, we can set the IPRs. We can set the, we can check dynamically check the IPRs, move the individual teeth. So when we automatically adjust IPRs, if you notice there is a very slight movement of the crowns. So this way we can get rid of any collisions between the teeth just in one mouse click. As you can tell from this, the operations to align the teeth is going from some rough idea to final. So you adjust the positions roughly along the curve. You want to push, you want to expand the jaw, you move buccally, or otherwise you move lingually. You do very rough placements. Then we let the system do the work to finalize the positions to not only reflect your idea, but also to remove the collisions between the adjacent teeth and between the antagonists. So we do this two-step thing. You do the approximate adjustment, and system take care of the refinement part. And also when we adjust the positions of the crowns, we actually adjust the occlusions. Or check the occlusions dynamically. Now we go to, let's go to the movement planning. This is a manual adjustment of the crowns for the lower jaw. It's a similar process. Let's go back to the movements placement. We'll do a simulation. We play back the movements. While the movements is being simulated, you can rotate the view and to see it from different orientations. Now in the lower part, there is a table there showing you for each of the teeth the number of steps, the translation of each of the steps. You can also switch to the display to translate from translation to intrusion, extrusion, rotation, etc. You can do different things. Here, all the staging operations, frame operations can be done here. You can determine, you can delete steps or insert steps. So we insert steps here because the movement is more than 200 microns. We increase the steps. This way you can have a very accurate control. You know how much you are actually moving. Instead of just getting a rough number saying 10 steps, but you have no idea how the 10 steps are. So this is how you can do a fine control to the movements. Adding steps, then you can set different order of the steps. So first we go through all of the teeth to make sure the movements are not too much, or we for anterior, posterior, maybe we want to lower the amount, but the anterior maybe we want to increase the amount a little bit. So that's what we can do. Then we can define the different orders. Like this one here, we define certain teeth move first, certain move later. That's how we set the start point of each of the crowns. So all the movement controls are down here. You can set orders, define keyframes. Let's say you want to expand the jaw, and then you want to move the teeth back. Then you can have two stages. The first stage you do the expansion, and the second stage you do the orientation adjustment. So we can do all of those things. And also we can do further control. We want to say rotation first, then extrusion, for example. You have those controls here in the system. Or you say, I want to complete all the translations first, then do a rotation. Or you want to say, I want to put all the translations on the second stage. You can do all those kind of things. And also you can define a static stage, meaning, let's say for a single tooth, you want them to stay there for 10 steps. You can do those kind of tricks. So that's basically for the purpose to make sure the tooth movements are feasible or not too much in each of the steps, and to avoid any collisions in the middle. Actually, for aligner restart, over years we have found, even though we tell the patients to be compliant with the requirements, but sometimes it's the plan itself, including the collisions between the crowns in the middle, and also the collisions between the roots, especially the roots. When you don't have a CBCT data, it's very hard to tell if the positions, if the movements are good, are not going to cause the collisions of the roots. So that's why we introduce CBCT in the process. That will actually make the treatment plan much safer and easier to follow. We can also generate a reference step. For this one, the purple model is the beginning. We set it as a reference step so that we know for each of the steps how much deviations they are from the original. You can do a visual check. This checking will help you not only to identify how much, roughly how much a tooth is moved. If there is a roots here, we can actually tell how much the roots are moved, so that we can avoid big movements of the rotation centers. This way you can make sure the movements is feasible and easier to perform. Very often we have found that even with slight movements of the crowns, the rotation center of the tooth or the roots itself can have a very big difference. So with the assistance of root models, we can actually do a better job to minimize the steps, and also to ensure, if not to minimize the steps, but to minimize the movements of the rotation centers, so that we know a plan is easier to carry out. Then we do all those kind of adjustments, define different orders, etc. Now let's go to the next stage of the process. We'll spend a little bit more on this side. Now we add attachments, and then we can add power ridges. The purple one is attachments, and the green one is where you want to add the power ridges. And we can have regular rectangular attachments, rotation attachments, and we can also have user-defined attachments. So is power ridge function. We have different shapes, predetermined defined shapes, but users can always use their own STL files. So that's why we call it ourselves an open system. It's really open, and you can do whatever you want to do to customize those functions. We also have additional functions to scale the attachments and to smooth the attachments. We got all those functions in the system. Then we can generate the model by adding case tags first. And we put a case tag there, and the numbers will follow this name. So then when we finish the generation of the models, each of them will come with a number. Then we add a base model for the printing purposes. If you want to vertically print all those models, we place all of them on a single plate like that. This way, when you generate supporting structure, you will not have a bunch of structures in the middle. So that will give you a better and easier way to handle the printed models. So we create a folder, and we put all the designed models in this folder. So we're done with the model generation. We have a function to add any models into the system, so we can take any one and take a look at it. Now we show some other things. We close the model and the project and reopen it. So we can load all the models here. So we take a middle scan. This is to simulate the replan. We take a middle scan. We can take a look, and we know it's not same as any of the stages. Here what we're doing is we adjust the plan, the first plan we had, just to simulate that middle model is different from any of the stages now. So we, in other words, we are simulating, in this demo we are simulating the actual situation. The plan is off. So the middle scan is not same as any of the steps. Now we load the middle scan. So you see here, we tell the system we are doing treatment stage step 8. And our system loads the model of the stage 8 and try to figure out which step it actually is close to. It tells us it's close to step 9. So we simulate the step 9, and after it automatically regenerates the crown models based on the middle scan. Then we generate the steps after step 9, and then we create all the models afterwards. Also we add a case tag here. We generate all the models. So that's what we have in the system as additional module for replan a case. You have an initial plan, you take a middle, in the middle of the treatment, you take a scan, we generate the rest of it automatically. You don't have to go through the redesign process. It's very efficient. And of course, if you want to have some adjustment, you can still just go in there, manually make the movements adjustment. But the replan function is really an easy way to go to set up the plan modification in the middle. And also in this design version, of course, we can do the same thing as we do in the clinical version. We can do the report generation. What we're doing now here is we're trying to load all of those models, and so you can see in the system step by step how the models are changed. The system got lots of additional functions you can play with. This is one of them. So we load multiple files in one step. You can simulate the movements. Now we are going to the next stage. We switch to the bracket bonding guides design. We go there, open a project, select the bracket brand, automatically place all the brackets. Now you see here we have the final arch curve shape. I mean, not the final, the beginning of the arch wire shape. Now we snap the arch wire and the brackets onto the same plane, and we can adjust the occlusion plane. As you see here for the lower jaw, we want to adjust a little bit of angle, so we do that. This will make sure all the brackets are on the tooth surfaces nicely. And the anchorage abutment function is anchorage implant function is here, and of course for this case we don't need to do that. You see here how we move the brackets. It's going to be automatically snap onto the tooth surfaces, because the base model of the brackets is not same as crown surfaces. It also has different torque values too. So what we do is we automatically snap the brackets onto the tooth surfaces. And also we have those refine controlment. You can just use those functions to move the brackets. Now let's take a look at the bracket bonding guide design. With our adaptive bonding guides technology as approach, the bracket bonding guide can be a single piece guide print with hard material. You never need soft material, hard material, the multiple materials you never need. You just need one single piece of guide with simple printing. Then you can do the bonding guides. The only thing is we have this bracket extension structure, which we have come up with some bracket manufacturers. And we are open to all bracket companies. If any of you are using bracket from any companies, please just, if you need, tell us or make an introduction. We can integrate their brackets into the system, and we can also help design a special guides for the bracket system, so we can very easily do the customized development for each of the bracket brands. What you see here is the way we design bracket bonding guides. It typically takes less than 2 minutes to finish, and you can define a whole piece, whole arch, make a guide for entire arch, or you can split into multiple sections. It's all up to you, but it's possible to do just one guide for one arch. The only thing is you need the bracket supporting structure, extension structure, which we are now offering with our partner. We offer the combination of the brackets and the extension structure all together in one pack. So what you do is when you get your guide, you insert the extension structure, and you can finish the bonding very easily. And it's actually very accurate too. So this is to show you for lower jaw we define owning section of it. Now we show the brackets, guide, and the extension structures. So this is how the guide looks like. It's very different from any other bracket bonding guides, but I'm sure it's the simplest one you really want to have. Just do one print, you have it. So those are the extension structures. And also you can go ahead and simulate the movements of everything. Well, this probably is not the right simulation, but in actual treatment you never keep those extensions, of course. So that's the bracket part. This short video shows you how it works. So far we have gone through the major workflow and functions of the software, and we have a little bit more to cover, and I appreciate your patience with me. So let's take a look at the case. We have a CT data. Going to show a couple of things. We show how we load the patient's CT data. What you see now on the screen is the volume of interest is just this small box, not the full head. So that's why you see it's cut a little bit. But this is how you define a case with CT data. You load the CT and give your patient's information, everything. And we can adjust the bounding box and threshold. You see the full arch here. Adjust the arch curves. This is similar to implant software, because we have been doing implant system for a long time. Lots of CT imaging processing and the functions can come from the implant system. By the way, if any of you want to know a little bit more about the implant system, maybe we can later on work on another webinar to make introductions. So that's to do a panoramic view of the CT and to load the patient's model scan. We can load both the lower jaw and upper jaw, close the model as we did. We can do jaw segmentation and the registration between the two. For the alignment, registration between the opticals.
Frank,
Yes,
can I ask you something? Here we can also add intraoral scans instead of modules
yes. Um,
in
since
this.
system is
Oh,
very
okay.
open, you can do anything. Intraoral scan, model scan, facial scan. So even denture design, whatever you have, you can load and register them. And for the registration between the models, what we can do is actually, you see here in the demo, you give 3 points. But in actual case, those 3 points, you can have multiple, and also those points will, they don't have to be one-on-one correspondence. And even they can be like 1 millimeter off, its system is still going to find out good results of that. So that's to show you the registration part. Let's take a quick look at the tooth movements part. Now we have the jaw, we have the crowns and roots and everything. Now we can simulate the movements. This is a little bit too fast. What we want to show here is actually with the roots. It's very easy to determine if the orientation is good or not. And you have a reference, is the bone structures are the references. So you know whether the tooth movements is too much or is enough, or whether it's possible or it's going to hit the cortical bone. So that gives you a very good reference. And when we look at the roots from the occlusion side or from the apical side, you can see how they aligned vertically. This is how you move the tooth when with or without showing the roots. So this not only gives you the idea how much root movements can be, and you can make your judgment if the bone adaptation is feasible. And typically, we probably have some idea how much bone reconstruction can be done. So that way we can make sure the movement is not exceeding the limit, so that to ensure the movement is easier to do, is feasible. So that's the process to adjust the movements. And of course, you can do the simulations like that. We turn on every models, and we can define the plans, and we simulate the movements like that. So everyone, thank you again for being with us, and this is pretty much what we want to cover in this webinar, just to showing what the major tasks are in orthodontic design workflow, and what functions we have from aligner to brackets, and what version of the software we have. We have the clinical version, and for the lab version. The lab version is really oriented for large, massive manufacturing of the aligners. So it gets all those functions. You pretty much do everything in the system. You don't need, very, very rare, you would need other systems to fix the models, to pre-processing stuff. You have everything in the system. That's good for you to finish everything. That's that has been our intention, our philosophy, that we make sure you get every single tools you have in a single system and a single workflow. Now I guess I'm going to give this back to Cyrus and for everybody to do a question and answer session.
Well, first of all, I want to talk about your presentation, us a lot about your software and what it's capable to do. It covers all the needs of an ortho clinic and also an ortho lab from all perspectives. So let's go ahead and go to answer some questions that we have on Q&A. So I have several times the question that if GuideMia is working on Mac laptops or Mac Pro, is it working on Mac or only on Windows PC?
It's actually only Windows for now.
Okay. Another question that we have for Sergio is that how big is the bracket library of GuideMia?
Right now we only have 3-4 brands. We do need to expand this, but as I said earlier, with our adaptive technology, we actually don't need. We eventually we will have a process independent of the bracket files. So any files will do, and we are finding a patent application for a tool that will help you to work with any bracket brand. But right now, yeah, we still need to work with bracket companies.
Okay, so Sergio, I think you got your answer. So in case you have a specific brand that you're using for brackets, directly with Frank and or refer Frank to the company that you're working with, so they can do the integration for you and you can take the most of the software. Sergio, basically Frank is a user for medit 500 and he was looking this moment for a good software for ortho. So I think you can make the integration steps that he might need from his side. So let's see other questions that we have. So I would like to ask the participants, do we have any other questions regarding the software or basically their combination? Whatever you would like, you're more than welcome to ask me or Frank about specific needs that you might need to know that can be covered through this combination or specific features that you would like to see us. We have, I think, another question. Frank, Sergio is asking how he can contact you. Can you please leave is it possible to leave your email on the chat?
Sure, I'll do that.
For Sergio.
Yeah, I put my...
So Sergio, right now Frank will leave his email. So you will contact him directly on this email that you see on the chat and discuss together how he can provide you his software, how you can test it, how you can also see, because keep in mind that GuideMia is not only a product, but it's also a company that provides services. So in case you want Frank also to provide you the services that you're looking to do in-house, this can be also done. I think Frank can explain us about that, how this works. If somebody would like from the users, for the i500 users from medit, they want to send their data, so please let us know about that, Frank.
Yeah, we
how they
actually
can receive services.
design services too. We have this portal and we have products on our website on the shop page, the store page. You can go there and book design service, and then it will take you to the steps to upload data. And I guess we can further work with medit to set up the link from medit's portal to ours.
Yeah, we can do that. Also, that's also possible. Any other questions, people that you would like to ask about GuideMia system, about our system, integration between them, or basically anything else that you would like to see regarding GuideMia, a specific function. Again, as far as I know, for anybody, if we have partners that they are watching also this webinar, keep in mind that also